Like this? Okay. Good. Thank you, everyone, for being here. Wikimedia, the organization behind Wikipedia, has the mission of creating a world where everyone can share in the sum of all human knowledge. How far is this mission progressed? Let's take a look at an example. This is the city of Winterthur in Switzerland. Manuel Sichel became a Wikipedian around 2004 and started editing all kinds of articles on Wikipedia. And one of the articles was his hometown of Winterthur. So he went for the article, went for the history, demography, and so on. And one of the things that he entered and improved was the section on sister cities in the article on Winterthur. So he entered the sister cities that he knew, he checked them, he put them there. Everything fine. At around the same time, 2004, 2005, someone created an article for the city of Ontario, California, which is close to Los Angeles, about an hour away if there's no traffic, which is basically never, so about 2 or 3 hours away in reality. So Ontario also has an article in Wikipedia, and it has a section about the sister cities. And if you look, you will notice that Winterthur is listed in the sister cities of Ontario, but Ontario was not listed in the sister cities of Winterthur, and this is usually a reciprocal thing, so you would expect that those would be fitting there. So even though Manuel stayed active on the Winterthur article for the next decade and even longer, he's still working on it today, over a decade, no one has told him about this discrepancy. No one told him, oh, look, there's someone claiming that Ontario is a sister city, but you don't have it on your article. So really, we failed, even Manuel, who was very deeply versed into Wikipedia, about letting him to share in the sum of all knowledge is already there. He wouldn't know it. He couldn't access it. The knowledge was there, it was written, and it could have, he could have just went through all the articles about cities and see, well, there was one of them mentioning Winterthur, but why would you do that? The problem is that meaning, that content is really easily hidden in natural language. And we all have this problem in many, many different places. As soon as you have a company that has like more than 10 people, you'll probably have a problem with knowledge management. You will probably have a lot of texts, you will probably have a lot of documents, and there will be a lot of answers to your questions. But it's so hard to actually find the right documents at the right time. It's so hard to find the actual answers to your questions, even though you know you probably have them somewhere in your archive. And the same thing is true for Wikipedia. There are a lot of answers to many, many questions in there, but they're hard to get out. Enter Wikidata. Wikidata has a explicit goal to solve this issue. How? By structuring the knowledge that is inside of Wikidata. You notice you wouldn't be here at the Semantic Enterprise MediaWiki Conference if you didn't know about that. So what is Wikidata? It is an open knowledge graph that anyone can contribute to, that anyone can use for any purpose. It's licensed under a CC0 license, which basically means available to everyone. It's powering several parts of Wikipedia. We'll get to this in details later. Launched 2012, provides persistent identifiers for all the topics that Wikipedia care about and well beyond and so on. The original funding came from a number of organizations and companies. My favorite of those was actually the money from IBM Watson. That money was the prize money they got from winning the Jeopardy challenge. And they gave it to Wikidata, understanding that this would be really helpful for them. So how does Wikidata look like if you look at the page? So this is the entry for Ontario, California in Wikidata. The page is a little bit busy, it's not particularly pretty, but it's very functional. We don't expect a lot of readers coming directly to Wikidata and read the content there. So we never put too much effort into making it too pretty. We always expected there would be alternative UIs on top of them using and displaying the data. So one part here is this box, which has all the articles about Ontario in the different Wikipedia language editions. So it says, for example, well, in the Bulgarian Wikipedia, this is the article. In the Spanish one, this is the name of the article, and so on. So all the Wikipedias actually pull this information from Wikidata and say, well, this is the article in the other languages. Just this box alone removed about 240 million lines of wiki text from the Wikipedia projects and reduced the amount of busy editing to the Wikipedia projects considerably. Okay, so the next thing is the term box. How is this thing actually called? Let's take a closer look. So we have, in different languages, Wikipedia supports about 400 different languages. Sorry, Wikidata supports about 400 different languages. We have the name of it in that language. We have a short description in the given language and other names for searching purposes. And then one thing is also we have a Q identifier. So everything in Wikidata has this Q identifier, which provides the identity of the topic. So the identity is not given by the name, because Ontario could be ambiguous. There might be not only one Ontario in the world, and in fact there isn't. But the Q identifier provides the identity of this topic. And when it's connecting to something, everything there is just those identifiers, which has a huge advantage, because this means that we can take the site of the Wikidata page and just switch the language. Like we can say, oh, this is it in English, and this is it in Russian. And it's exactly the same content, because it's actually connecting those abstract identifiers to each other, and we can just put the labels on top of it. So when you edit and the thing is, you cannot only read it in Russian, you can actually go and edit in Russian, and it will edit the same database that you would have edited if you were editing it in English. So all the different contributors in the different languages work on the very same knowledge graph and collaborate across languages on it. This also works in languages with really pretty scripts, or in right-to-left languages like Hebrew and so on. Okay, the next part of Wikidata are the statements down here. Let's take a closer look at a few statements. So every statement, here are two statements, one bigger and one smaller. The statement here, so the statement is basically a triple, similar to Semantic MediaWiki. The subject of the page is also the subject of the triple. Then we have a property, and we have an object to the statement. The property here is twinned administrative body, which is a little bit more generic version of sister city. And then the object in the first statement is winter tour. And so this up there makes the claim, the heart of the statement, really. And which consists of the triple, the subject being Ontario, predicate, object, and then we have also a few qualifiers, which are further key value pairs, which might qualify the claim in some ways, making it a little bit more complex than the Semantic MediaWiki data model. The next thing, and really core to Wikidata, are the references. So every statement in Wikidata, every claim in Wikidata may have references. And the references basically tell you who is supporting the statement, where does the statement come from, what's the actual reference. It's the same thing with Wikipedia. And this is a really important part of Wikidata, because at the core of Wikidata lies the belief that Wikidata is not about the truth. We're not trying to tell the world how the world is. What Wikidata is trying to do is collect statements from sources about entities in the world, how they relate to each other according to those sources, and reflect the sources. This helps a lot with not getting too many edit wars going on. Because what you're actually saying is now, well, not Jerusalem is the capital of Israel or not. What you're saying is, Jerusalem is the capital of Israel according, for example, to the Israeli constitution, because that's what it says there. But then there's this other source which might disagree with that. And you can't really fight about whether the source says that or not, because you can just go ahead and look it up if it does say that. So this pushes the edit wars to a different level than we are used to, because we're actually just reflecting what the different sources are saying. And then the user can choose which sources they want to believe and not. Okay, so this is how statements look like in Wikidata, a bit more complicated as in Semantic MediaWiki, which is because of the slightly different use cases that Wikidata is aiming at than Semantic MediaWiki. So at some point after Wikidata's launch, someone came along, came to the Ontario article, and saw the sister cities, entered them into Wikidata, and there they landed them. And so the information from Wikipedia and other sources is slowly being formalized inside of Wikidata. At least a very small subset of it. It can actually be captured by Wikidata, and it's limited exclusivity. So how is this information then used? Well, this is the article in Ontario. So one place where you can obviously use it is in the info boxes. The info boxes often display information that that easily fits the mold that Wikidata can actually capture. So you could just ask Wikidata and display this stuff. The other place is the language links, as discussed before. They come from Wikidata. And then often, at the bottom of an article, you have those authority control links where you say, oh yeah, in those other databases, this thing, what we're talking about here, Ontario, California, has this particular key. So you have here in Music Brains, in NRA, and in other sources. In fact, Wikidata links to more than 3,700 different such catalogs all over the world. And this is a huge number, and it's growing very rapidly, usually by the number of 2 or 3 per day. So for Ontario here, we have the Demos ID, the Freebase ID, Music Brains, GeoNames, Facebook, and so on and so on. Dozens of those links. And this means, Wikidata doesn't try to pull in all the data into itself. What it really does is being the place where you can actually go and look it up. Okay, so how do I call this entity over in that database? And then you can go to the other database and actually integrate this information if you want to. This makes Wikidata into a form of Rosetta Stone for the web. You have the names of everything in all those different databases, all those different identities saying, well, this is basically the same thing. And more of those external authority control pages are actually going and saying, well, we should use Wikidata as our as the external identifier. So the Library of Congress is now linking directly to Wikidata QIDs. The German National Library, more and more other national libraries are linking directly to Wikidata. Museums are using the Wikidata terminology, using the Wikidata identifier to identify their own catalogs and so on. And this is growing more and more. So Wikidata is becoming the core of this web of data that can point to all these other different databases, and you can just go to Wikidata, find it, translate your own terms, and so on. So this makes it into really the middle of a big web of linked data that is out there, which doesn't have all to be in Wikidata, but you have the identifiers in Wikidata. You can look up how this information is called in other databases. One example for that is schema.org. Vocabulary released by consortium about describing all kinds of things on the web, so that it can be more easily found. And schema.org is a stunning success. About 31%. There are about 12 million publishers publishing data in schema.org, and about 31% of the web, about a third of the web, has actually annotations and structured data. Saying basically the linked data is everywhere. It's out there and widely used. Datacoms.org, on the other side, is a project that tries to then connect those different data sources and make them available in a cloud platform, so you can just ask there and get this information together, not only from Wikidata, but also from other sources. So, how is Wikidata doing? A few numbers. Oh, before we start with the numbers, so one of these here is a photograph done by NASA. The other one is a generated image where it just took the geo-coordinates from Wikidata and put a little dot wherever there was a geo-coordinate. What do you think is the NASA one? The upper one? Who's for upper? Who's for lower? At least the NASA folks knows. So this is actually NASA, and this is generated. But you can tell that the completeness is kind of there already. And this is actually pretty much true for the whole world, not just for the United States. So you get a pretty nice view of the world just from taking the data from Wikidata and generating an image. There are more than 55 million items being described in Wikidata right now, and the number is growing rapidly. There are almost 700 million statements describing those items, connecting them with each other, creating this big graph of knowledge that you can access. 400 languages, as said, which is about 100 languages more than Wikipedia. And this is the number I'm most happy about. There are more than 21,000 monthly active contributors on Wikidata, which is a great number. It makes it the second largest Wikimedia project, close with Commons. Sometimes it's Commons ahead if they have an action going on. Sometimes it's Wikidata, but they're basically competing. Just the English Wikipedia is definitively larger, but Wikidata is larger than the German Wikipedia or any other Wikipedia, for example, in numbers of active contributors. There have been more than 900 million edits to Wikidata. This is in a pretty short time frame since it has launched in 2012. So just to compare the English Wikipedia, actually just 2 weeks ago, Wikidata had more edits than the English Wikipedia, even though the English Wikipedia has been around for 3 times the time. Among those edits, here's my favorite edit. I will quickly explain it to you. So this one, does anyone know the TV show My Little Pony? My daughter loves it, that's why I'm... So there's one character called Spike. He's a dragon. And in this edit, what happened is that Spike was previously a dragon, has been changed to be a fictional dragon from now on. Yeah, I just love this edit. So 900 million edits, including the one to Spike. And one of the interesting things is, so this is now the edits happening to all of Wikimedia projects over the last, well, since its inception, basically. So this is Wikipedia, the English Wikipedia was created, and so on. So the yellow ones here are human edits, and green ones are bot edits. So you can see pretty clearly 3 distinct phases. So the first phase was the honeymoon phase. The numbers were going up exponentially. It looked like Wikipedia will take over the world. By 2020, everyone will be a Wikipedian, and they will have described everything in every language out there. It was a wonderful time. Then came the oh shit moment around 2007. This is when the curve suddenly flattened, and everyone was like, what happened here? And there's been tons of research work trying to figure out what was going on. And basically, for the whole time, everything stayed flat. Then came, this is the release of Wikidata. And since then, the graph has been growing again. And the whole growth here can be entirely attributed to Wikidata. So this is just the Wikidata editing happening here. The rest of the projects are actually as flat as before, unfortunately. But hey, we have growth again in the number of edits. This is also a super surprising number to me. There are 8.5 million Sparkle queries every day. When we started the project, I didn't have Sparkle particularly high on my to-do list because I thought no one's using Sparkle out there. No one's using RDF. No one really cares about those things. And I'm actually a semantic web researcher, so I really did care about it. But I was like, we shouldn't use our time and resources on that because there's other stuff we should be doing instead. Fun fact is, the Sparkle endpoint does work. It's been stable, which has been totally surprising to me. It's keeping up to date with the changes on Wikidata. It's usually like 2 or 3 seconds behind, so there's minimal lag. You make an edit to Wikidata, it will be there immediately in the Sparkle endpoint. And more people are actually learning Sparkle, and they have communities, and the Wikidata community is one of the largest contributors to this to growth of Sparkle, and there are articles about how to use it, how to use the endpoint, and so on. So Sparkle, just to quickly say, it's a standardized W3C query language for graph data, And just like in Semantic MediaWiki or in Wikidata, well, the content is basically graph data, so you can just use this to query it, to find patterns in the data and display the results. Now, the Sparkle endpoint of Wikidata is particularly nice. The UI is really friendly. It has auto-completion and all of these things. But also the output has, directly out of the box, different ways to visualize the results. So if I ask for example, for the, all the images done by Picasso, I don't just have to get back a table or a list in JSON or XML, and then I can use it in my own software. But I can also create actually a gallery out of those things, directly out of the Sparkle endpoint, and create a link and send this link around to people who can then go and see the results. The same thing works with timelines. This, for example, a timeline of space probe starts coming directly out of Wikidata, and it's interactive. You can zoom in, you can scroll back and forth, and all these things. You can create visualizations like the causes of death of people who have a Wikipedia biography, and where this is actually added, and then visualize how often certain causes happen. Or the population of Germany according to Wikidata, and so on. You can also create maps, like for example this map, the sister cities of Winterthur. And this is in fact the map that Manuel Sichel has created a while after he discovered Wikidata. He wanted to get a nice visualization of the sister cities of Winterthur, and he was expecting those results in Europe. But Wikidata also told him, hey, there's someone here. And he was like, who? I didn't know about that. And the thing is, Manuel has, in the 10 years since he started editing, actually now 15 years almost, since he started editing Wikipedia, he has become a council member of Winterthur, of the city of Winterthur. So he was like, I really should know about that. So he first thought, well, it's probably vandalism. So he took a look at the Wikidata entry, and I was like saying, oh, this was imported from the English Wikipedia. Okay, well, then it was vandalism in the English Wikipedia. So he went to the English Wikipedia. And there it was entered a long time ago, like 2006 or whatever. But it was entered with a reference. And the reference was pointing to the official government site of Ontario. So, oh. So he went to the official government site and saw, yes, they actually list Winterthur as a sister city. So he was like, huh? Something's off here. So he asked his own city government and the archives of Winterthur, do you know anything about this? And they were like, no, never heard about it. So we have no idea why they claimed it. So okay. So he set up an official letter and wrote to Ontario. And Ontario answered, and they were, yeah, totally, here are the papers, the signatures and everything. Since the 1980s, Winterthur has been our sister city. And now with the signatures, you saw it was the signature of the previous mayor, who was a mayor in the 80s, and he was still alive. So he went to him and was asking, do you know anything about this? You signed it. I mean, do you remember anything? And the mayor was like, oh, yeah, totally. I was at a conference in the US, and it was all kind of mayors. He met the one from Ontario. They hit it right off, and they really liked each other, so they made each other sister cities. And he did send all this data to the city council for approval and so on. And with this information, Manuel now went again to the archive, and now they were like, oh yeah, we do actually know about this. Because basically he told them what they have to find, and then they could find it. And that's exactly the point that I was making previously. They had the documents in the archives. They had all this there, but they couldn't find it because they didn't know what to look for, where to look for it, and so on, because it was all hidden between the other things. Now when he came with, it was 1982, it was signed by this guy and so on, they were like, oh yeah, sure, we have actually all of the stuff here. So what happened since then is that Winterthur and Ontario renewed their sister cityness, and the City Council of Winterthur acknowledged the whole thing. It was all published in the newspapers, how Wikidata helped actually finding the long-lost sister city of Winterthur. And there are two things that we can learn from here. First, no one really cares about sister cities. And second, having your data just in text makes it really hard to find. So with Wikidata, we are getting a little bit closer to this goal of letting everyone share in the sum of all knowledge. Because you can make those queries in all the different languages, you can visualize the knowledge from the Wikipedias and beyond, and all these things. You can get closer to this goal and letting everyone be a part of it. So are we there? Mission accomplished? No, not really. There's stuff missing. And the biggest problem is that the expressivity of Wikidata is very limited. I mean, you can say stuff like Winterthur is the sister city of Ontario since 1982, but those statements are super, super limited. There's a lot of stuff in the Wikipedias or in natural language that isn't easily expressible in this kind of formalism. Let's take one sentence from the Ontario article. To impress visitors and potential settlers with the abundance of water in Ontario, a fountain was placed at the Southern Pacific Railway Station. Putting this into structured form, not easy. It's getting even harder with the next sentence. It was turned on when passengers train were approaching and frugally turned off again after the departure. This is really nice information. You want to read that on the article. It's interesting, it's amusing, it's nice. But how do you express this in triples? This is a big problem. So Wikipedia today has almost 300 languages, and there are 49.8 million articles. And this sounds pretty impressive, pretty amazing. It's like a huge number. But the thing is that those articles are not evenly spread across the languages, not even close. English has like 5.8 million articles. There's an article on basically everything. I mean, every single Simpsons episode has an article. Every city of importance has an article. There's just tons. Cherokee has 837 articles. That's not enough. This is not a complete Wikipedia. There are 15 languages that have more than 1 million articles, 16 languages have 100,000, but half of the languages have less than 10,000 articles. And so we see that the distribution of articles across languages is very uneven. But it's not just that, you know. This is the article about the city of Frankfurt in Germany in the English Wikipedia. Actually, sorry, this is the first 3 paragraphs of the header of the article. And actually, if you scroll a little bit down, you get to the table of content of this article. So this is the table of content of the article about Frankfurt in the English Wikipedia. It goes on over 3 pages. It's a really long, really detailed article with all kinds of information. Now when we go to the Catalan Wikipedia, the Frankfurt article is a little bit shorter. We say, well, Frankfurt at Main, in German, Frankfurt am Main, is a German city in the federal state of Hessen, and the population is 732,688, which is outdated by now. And then we have a link to the soccer club of Frankfurt. And that's it. It's not exactly comprehensive. So we see that it's not only the number of articles, but this is an article, obviously, but it's not only the number of articles, also what kind of knowledge they cover within the article can vary dramatically. And it's not just, you know, the English Wikipedia is everything and the others are all small, but sometimes it's the other way around. This is the article about the port of Călărași in Romania in the English Wikipedia. It's one of the largest Romanian river ports located in the city of Călărași at the Danube River. That's it. That's the whole article. If you go to the Romanian Wikipedia, you get a picture, you get much more data, you get much more information. And all of this is locked away if you don't speak Romanian. And the coverage is not only between the articles or across the numbers, it's also what topics are actually covered. So there's 2 biggest Wikipedias by activity are the English and the German Wikipedia. The German Wikipedia has 2.2 million articles. The English Wikipedia has 5.9 million articles. How many articles do you think how many topics are covered by articles in both languages? Anyone want to make a guess? Is it like 80% of the German articles have actually topics in the English one? 50, 40? 50% mark, okay. Anyone else? 90, sounds reasonable. 90% of the topics here should have articles in the English one. Mark is completely right, it's 50%, 1.1 million. So there are 1.1 million topics that the German Wikipedia has articles about that the English Wikipedia doesn't even know about. There's a huge amount of knowledge which is locked away also from the English Wikipedia, no matter how big it seems. And the thing is that if you look at the top 10 Wikipedias by activity, there are only 100,000 articles that all of the 10 have in common. All of the other ones are missing in some of those. If you look at the top 20, you'll get down to 25,000 articles. And we're still at Wikipedia that are almost 1 million articles big. So there's a whole lot of knowledge which is only available in certain languages but not in others. In fact, there are about 17.9 million topics, distinct topics that have Wikipedia articles across all those 300 languages. And the English Wikipedia only covers 31% of them. There's almost 70% of topics that don't have an article in the English Wikipedia. And the headroom for having new articles is basically 12 million more topics. It's not just the articles. This is the result. The actual input, the actual size is the size of the communities. In total, we have about 69,000 active Wikipedians. English is 31,000. This is by far the largest community. The second largest one is German with 5,500. And after that, it trails very quickly down. We have 11 languages with more than 1,000 editors, and half of the language editions of Wikipedias have fewer than 10 active contributors. You can't write an encyclopedia with 10 contributors in the free time. It just won't result in a comprehensive Wikipedia. There's no chance you can achieve, actually. This means half of the languages of Wikipedia are currently in the setup basically doomed, no matter what we do. Here comes now my suggestion. The belief is that the root cause is that solving Wikimedia's mission is basically costs the number of topics times the number of languages. So this is in some made up unit, 20 million topics, 300 languages, 6 billion cost units, whatever it is. And the suggestion is, can we switch that so that the cost of solving this becomes number of topics plus number of languages? Is there a way we can turn that little X sign around for a few degrees? And maybe. So the idea is that we take the content from the Wikipedias and try to express them in a formal way. Try to put them in something like frame-like expression. Let's say, okay, so this is a ranking. This is a ranking about San Francisco, saying it's a city, the 4th city by population in California, after LA, San Diego, and San Jose. So this sentence, or this frame, could be expressed in English language as San Francisco is the 4th largest city in California, after Los Angeles, San Diego, and San Jose. It could also be expressed as following Los Angeles, San Diego, and San Jose, San Francisco, 4th most populous city. It doesn't really matter. I mean, the content of both of those sentences is basically the same. So if we could somehow capture the content of the Wikipedias in such a way and have translators, linearizers, who can turn this into sentences, could we get faster to our mission? Could we get more coverage in a faster way, and could we get more recent content? So we would have this kind of constructors, and those obviously would be community created. We can't, the assumption that any small set of developers could create a comprehensive set of constructors is too far-fetched. So we could have those constructors created by the community. We could have the content, which is by far the largest part, also created by the community, and then have renderers for each of the languages. Like, this is just some toy example saying, well, subject is the ordinal rank largest object by criteria in local constraint after. Something like that, you know, which creates in the sentence. Obviously, this is completely oversimplifying. And English is particularly neat for this kind of hacking together, because language is such a nice language that doesn't do things like too much agreement and cases and stuff like this. So it's particularly easy to show these things in English. But the claim is maybe it's possible to actually get that. And particularly with having the linguistic knowledge becoming now a part of Wikidata as well. So we started a project last year that added linguistic knowledge to Wikidata, which has then information about word forms, their meanings, and so on, which could be used then for actually creating those articles. So the idea is we would have one renderer per language, about how many languages we ever support, then the contents per renderer and the constructors as a single set below that. And the content is obviously the biggest part. You could imagine a lot of UI-friendly stuff, like form-based editing and so on, working on top of those constructors and helping the users, particularly, for example, with novel editing interfaces like mobile phones and stuff like this, editing the content and creating it. So what makes this project hard is really that we want to make sure that the content is easy to contribute, as said, in any of the languages, just like with Wikidata. We want to have the constructors maintained by the community, but this also means they need to be able to edit the constructors anytime, and the system has still know how to cope with that when the constructors change. The renderers have to be maintained by the community because you can't create 300 teams and pay them to actually create those things. Everything has to be editable at any time, which is hard. I mean, but we have some experience with that. In Wikipedia, we have a similar problem with the templates and how they edit and how they grow and change. And we want to have graceful degradation. Just because one word form is missing in a specific language, we don't want to drop the whole article, for example. So we need to figure out what to do in those cases, how to drop parts of the article without making it nonsensical and without making it unusable. But there are also bright points that make the whole thing realistic. First, we're talking about a single genre of text. We're talking about encyclopedic text. Encyclopedic text is very different from essays, from poems, and so on. It's a very simple genre, which allows for being a little bit more boring than many other genres, for example. There's also no need to actually parse and understand language, which is usually the hard part about natural language processing. We don't actually have to go and understand all the language, we just have to be able to generate it from structures which are actually edited directly by people. And we can start very simple, because the baseline is so low. You've seen the articles about Frankfurt in Catalan. You've seen the article about the port of Kalarash in English. We don't have to do that much in order to improve upon that. And the incentive infrastructure is very promising. What I mean with that is, if you are today a well-educated, if you're, for example, very educated in India, you probably speak English, and you probably speak a native language. And this native language might have a small number of speakers. And with small numbers, it could easily be like 10 million only or something like that, which is actually a pretty big number. But you see, there are not that many people actually editing Wikipedia in your native language. So your incentive to actually contribute to your native language instead of the English language, where your contributions will be seen by many more people, is very different. You might still contribute to both, or split your time, or you might decide that you're going for your own language. But there is some kind of conflict within your own valuable time, which one you do actually support. Do you write about your hometown in the English Wikipedia, making it accessible to so many people outside? Or do you write it in your own language, and with the risk that it won't be seen by many? And you know that those Wikipedias are doomed, as we have seen before, because there's so many people working on it, because of this decision, obviously. So the goal, the incentive infrastructure of creating everything in one space and making it available for all the languages is a very different one suddenly. And suddenly, you can actually have a shot at creating a comprehensive and current encyclopedia in your own native language, even for only 10 people, because all you need to do is the renderer. You don't have to care about the content if you don't want to. And the goal of the whole thing is really pretty attractive, because we are really getting closer to a world where everyone can share together at the same time in the sum of all human knowledge. Thank you for your attention.
So on the slide where you had the coverage by language with the articles that intersected, how confident are the numbers that you know that the tagging of cross-language translations for the article itself is correct? Like, is it possible that it's better coverage than that because we don't, the German language is missing a tag that this is what the name of the same article is in English?
It's a great question, and it's possible. We are pretty confident because this tagging is coming from the community, in particular between the German and the English community. The overlap of speakers who actually speak both languages is very high. So we assume that the quality of those is really good. Also, we did actually some checking on that. We did also machine learned approaches in order to figure out the tagging, see how much is missing. And the missing data set was among 60 languages, only like 40,000 links were missing. It's the 60 largest languages, which means that in the set of roughly 40 million articles, 40,000 links were missing, which is a really small number. So the confidence is really high.
How many Wikipedia languages currently utilize Wikidata extensively for info boxes? And is there any kind of desire to try to increase that?
All of the Wikipedias may use Wikidata. Not all of them do. And it's very unevenly distributed again. Some Wikipedias have a usage of Wikidata on basically every page where they have an info box, and they pull in a lot of the data from it. Catalan is a great example actually for that, where they pull a lot of the data from Wikidata and display it. Other Wikipedias are less friendly towards Wikidata. The nice thing though is that it's mostly the big Wikipedias which are careful about adopting Wikidata, which is totally fine because those Wikipedias already have a lot of eyeballs checking their own data. It is the smaller Wikipedias who will benefit most from Wikidata, and those are most open to that. Their limits seem actually to be in, is there enough knowledge to actually use Wikidata and to even know about Wikidata in the first place? So they're not limited, they're usually not limited by whether or not they should use Wikidata, but rather whether they can use Wikidata. And I don't know how to really reach out to those communities because they already speak a language that a lot of us don't. But it's very unevenly and but increasing at the same time. Also English and German are starting out to use it in certain areas. And I'm totally happy with each Wikipedia doing that at their own leisure. I'm a little bit unhappy about those who would like to use it more but can't. But this is better to be in the opposite position.
Hello. I just want to start by thanking for this work. I think it's it has a lot of amazing potentials. So thank you for that. In the context of where I work, which is healthcare in the U.S., privacy things like that is a big concern. How do we implement something like this internally? I mean, we have to have our silos in a way. I think it's an open source project, but anybody doing it in that regard, creating their own local Wikidata bases?
Right. So yes, there are a lot of companies that obviously have a lot of private data of the users, which you don't want to, or of external third parties, which you don't want to make too widely accessible, and that's normal. But even then, you will probably have a large set of common knowledge, which is actually totally public knowledge, which you could even put outside in the world and you wouldn't care. I mean, you probably need to know, for example, that certain cities are located at certain places or in certain states and so on. And the more of this kind of background knowledge you can use, the more intelligent queries you can do on those. Suddenly, then you can ask, okay, which of my data sets actually deal with the Rust Belt, for example? Which of my data sets, even without touching your actual sensitive data set, you can start by connecting to this common knowledge to make more intelligent questions to that. This is similar to what we do at Google as well. We obviously have a lot of data sets which are highly sensitive, and those don't go into the knowledge graph. I mean, that would be very not good. And we have a lot of knowledge which can be shared, which can be common along all the different PAs, along all the different areas we're working in. And for this knowledge alone, it's already often worth it to actually put it into a common place and to have then the others refer to the identifiers in this knowledge base. If all the potentially sensitive data starts talking in the same language as the common database, things become easier for you to actually connect those, even without having them in the actually, literally the same database, because for privacy reasons, which you totally want to support, right? And in that case, something like Wikidata can be a Kickstarter for your internal knowledge base, where you take certain parts of Wikidata, put it through some reviewing process and updating process, and connect then your own data set to it. This will help you with merging data sets across the company if they all use the same language and formalism. This can help you with all kinds of things without ever having to have put privacy at risk.
You said the expressivity of triples is not so good, a view which I share. You propose to structure the knowledge in more elaborate forms. Attractive. Then you propose to render it to other languages, I would say compile. But then natural languages are, well, unfortunately a bit complex, context sensitive. And then I had a quick look while you were speaking with the internet, and I got an immediate hit about, for instance, having a context-free grammar for English. So proposals exist in that field. And all of a sudden, I felt that your endeavor was not completely realistic. How far did you think in this direction? Which, by the way, is absolutely not my specialty. But is there any resonance in the academic world? Have you contacted Mr. Chomsky about that subject, for instance?
Well, I have not contacted Mr. Chomsky about this subject. I did talk with Mr. Fillmore about this subject when he was still alive. So I skipped over that part. It's in the white paper about it. Indeed, you need to carry context throughout the article. Whenever you have a constructor, like we have seen, it will build some context that the next constructor must be knowledgeable about it. And this is just necessary in order to make the text readable at all, because otherwise your articles will all sound like Ontario is a city in California. Ontario has a population of 500,000. Ontario is this. This is completely unreadable. So you need to have some representation of syntax, even just to keep the focus of the whole thing, which also makes it very different from standard knowledge representation approaches. Standard knowledge representation approaches always assume a declarative knowledge base, which means that every single sentence in your knowledge base or every single axiom in your knowledge base stands for itself. Which is also true, for example, for Semantic MediaWiki triples or Wikidata statements. They always stand for themselves, they're not in the context of everything else, which has a lot of advantages. Here we're throwing out this advantage in order to be able to actually generate readable text. This is challenging. There are projects who have done this before. Actually, Xerox started in the 80s with a project in order to encode the instruction manuals for many different languages in some kind of abstract language. And this line of research has been ongoing since the 80s and is still being done by a number of academic outlets. And I've been looking at those results in order to understand how realistic is this actually. And it's not easy. So I think the failure rate of this is pretty high, but it's not impossible. I think that we can get to decent articles in this kind of formalisms. Handwritten articles will always outperform this. There's no question about this. But the advantage is we don't have to cover all of the English language. Context-free grammars have a problem because they try to deal with all of language. They try to parse language. We don't have to do that. We can stay within a very limited fragment and get somewhere with that. How far we can really get with that, I don't know. We need to try. The risk is high, but the benefit is probably still worth it. But yeah, you're right. It's not a given that this works. It's definitely not a given. I would love, by the way, I would love to talk to Chomsky about this, but I think he would take it. Actually, I think he would probably state something about, well, his universal grammar theory about language has probably predicted that anyway, and it is obvious that it should work. This would be my first assumption about what Chomsky would think about that. And then he wouldn't care if it actually works or not.
So first of all, I'm very distraught to find out that My Little Pony is not real. Thank you for that. Show of hands, does anyone use Wikidata in their organization implementation of MediaWiki? So I see one hand. Yeah. Okay. And so, oh, and two. Okay. So I'm curious to hear your thoughts on comparing the use of Wikidata versus Cargo or Semantic MediaWiki, and why an organization would choose Wikidata over one of those two other options, and what reasons? Yeah,
that's a great question. First, very quickly about My Little Pony. The reason why Spike is a fictional dragon and not merely a dragon is that actually Wikidata makes a difference between fictional dragons and mythological dragons, and dragons, I think, in religion and so on. And in order to, and they all are dragons, so actually it's just a specification of it, but mythological dragons are treated differently than fictional ones. So here it's specified that he's actually a fictional one, not a mythological one. Regarding the second question, I don't think there is an either or at all here, because the Wikidata is one knowledge base out there that you can reuse as background knowledge if you want to. And for some organizations it may make sense, for others less so. Whereas Semantic MediaWiki and Cargo and other solutions are actually enabling you to do knowledge sharing inside of your organization. You can't use Wikidata for that. It doesn't, I mean, you wouldn't do knowledge sharing about your projects inside of Wikidata because you obviously don't want to do this in a public, well, you might actually want to do this in the public, but a lot of companies wouldn't want to do this in a public space. And they also don't want everyone to be able to edit these things. They have a certain authority over the data, and they want to keep a certain authority over this data. So using Wikidata and using Semantic MediaWiki has simply very different use cases. And if you were to build your own knowledge sharing inside of your organization, it just doesn't make sense to use Wikidata for that. If you want to do your knowledge sharing and then use a common background knowledge set, then Wikidata can become interesting. Then it would make sense to actually evaluate the content of Wikidata and to come up with a way to use some of it in order to just to kickstart your own background knowledge that you have inside of your organization and use this there. So I really think they are complementary and having very, very different use cases. There's a second question about the actual software used in those cases. So Wikibase, which is used in Wikidata, against Semantic MediaWiki and Cargo and similar things. And again, I think that they have very different use cases. And for some memory organizations like galleries, libraries, archives, and museums, the rich Wikidata model might be beneficial. In many cases, I think it's actually overkill. Having references for every statement, having competing statements and so on, is not something you usually want inside of your inside the knowledge management of your organization. This is just often overkill for this kind of organization because you know who the lead on this project is. You know what the task is, and so you don't want to have competing statements on those things. So I think that in most internal organization work, Semantic MediaWiki Cargo are definitively the better solution than Wikibase. There are certain use cases Wikibase and its strength of the richer data model have advantages, but yeah, and then we can basically discuss where the line is exactly. But I don't think there's that much overlap between those use cases.
So in the past couple of years, I worked with a research organization that publishes a wiki. And they have, you know, it's very structured data in their wiki. They had been putting their biological pathways that are in their wiki into Wikidata. Because that was public information that they want to share.
Right, yeah.
And Wikidata was already a pre-existing thing. They were looking at setting up perhaps their own Wikidata instance, but not, you know, I think they decided that wasn't needed.
Yeah, that's a perfect use case for such a thing where you want to actually go public with that.
Yeah, my understanding is that there is actually a growing community of third-party Wikibase users, which is very interesting compared to, you know, our growing third-party MediaWiki.
But those use cases seem, as far as I can tell, all coming from the memory institutions, from academic projects
really
and so on, which have those use cases, which makes it a lot of sense. But again, if you're a company and you want to do knowledge management, it's probably overkill.
So I wonder what type of data is in Wikidata, and specifically the Standard & Poor's 500 index of 500 largest corporations in America. Does that information make it, or does census data, you know, like not just population of my town, but literally me and my occupation, or that kind of census data, is that in Wikidata?
So for the census data, we have some basic census numbers. We intentionally did not put everything into Wikidata because we have to link to the census database. You want to actually what you want to know is, okay, this is now the city of San Francisco or your hometown. You want, what is the identifier over there? And then you can go and look actually, because they are authoritative. For data, why would you take it from Wikidata if you can actually get the actual authoritative data, which is just one hop away from the census itself? But we would have for every city, obviously, the identifiers and how they are linked inside of the city. The same is for the companies. So I'm very sure we have all the companies there and some basic information about them. And then we have links to other data sources that have authoritative data on those. And this is exactly how Wikidata is set up. So you wouldn't find everything in one place, but everything else should be just one hop away with more information.
Sorry, this is the Enterprise MediaWiki Conference, so I wonder if you know of any uses of Wikidata in business, whether it's the data or the identifiers for use in avoiding ambiguity.
Right, so the identifiers are actually used in a number of companies. Almost every tech company I talk to here in the Bay Area is using Wikidata identifiers. So be it Facebook or Google, or I gave a similar talk like this in Los Angeles a few weeks ago, and a person from Amazon came to me telling me, oh, how happy they are about Wikidata, and especially for movie data. And I'm like, wait, you're Amazon, you have IMDb. Why would you care about Wikidata for movies? And like, yeah, IMDb doesn't have data about budgets of movies. And I was like, okay, so, well, they were scraping this data from Wikipedia. But now with Wikidata, they actually have a database that tells them their own identifiers from IMDb and allows them to simply pull this data in a structured form, which is so much easier. So there are a lot of companies using the Wikidata identifiers, mapping to those, and using the data from Wikidata. Basically, every digital assistant that you, and probably on all of your smartphones, will be answering questions from Wikidata, whether be it Siri or the Google Assistant or Alexa. They're all using Wikidata data to answer these kind of queries. And we know that about Siri, even though they never confirmed it, because there was the case of someone changing the Bulgarian national anthem to Despacito, which is not the Bulgarian national anthem, just to make it very clear. And if you ask Siri during a certain time frame, what's the national anthem of Bulgaria, it was totally telling you Despacito and starting to sing it. So we know that they are using it, for example, even though they don't publicly say it. For the other companies, we actually have public statements that they are using Wikidata.
We have a question on Riot.
Mm-hmm.
What is Wikidata's stance on original research? Even if you are an organization that actually wants to put its data in the public domain, that might be a problem.
Yes, this might be a problem. Wikidata has a similar rule to original research as Wikipedia. This is not the place where you should publish original research. Also because how do you actually make sure that it stays the way you said it? Because anyone can go in and click edit. So what you should be doing is publish the data under a free license in your own place. And then you can still upload it to Wikidata and refer to your own database as the source. But really, you should be publishing it in an authoritative way yourself. And if you need help with that, I'm happy to help you with how to do that. But Wikidata is not the place to publish primary sources or original research.
Hi. What about the storing of typos? Do you use the storing of typos, RDF typos, and do you use some GraphDB typo store? What kind of tools? Because I saw that it's a huge number of typos.
Yes, it's a few billion triples. We are using BlazeGraph, which is an open source triple store. After a long evaluation, this was chosen as the one for Wikidata. And it works. I'm just very happy that it works. As far as I understand, there's actually a paper at ISWC about a triple store, how it's set up, and with more usage data and so on. Everything is public, obviously. It's the Wikimedia Foundation, after all. So I can point you to this paper with much more detailed information. In general, the triple store is challenging because it needs a big machine and so on, and Wikidata is growing so fast, but so far it seems to be working. What happens if Wikidata gets 10x bigger? Let's see.
All right, well, thank you, Denny. We appreciate your talk, and we're going to take a break now for 20 minutes, and we'll start up again with more talks afterwards. Thank you very much, Denny.
Thank you, everyone.